Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, in this video, let us discuss about a number of problems related to array concepts. So, let us start with what is an array. So, an array is nothing but a storage area which can store similar type of data in adjacent memory locations, and you can refer to any array elements by using the array name and its index position. Now, in every array, the array index starts from 0 and the maximum index value is array size minus 1. So, if you want to compute the size of an array, then it is nothing but the summation of size of its individual elements. For example, integer a of 10 is an array. Now, how to compute the size of this array? So, to compute the size of this array, suppose size of each element is 4 bytes. Then, how many elements you want to store? You want to store 10 elements. So, it will be 40 bytes. So, size of an array, you can say that size of the data type of integer. So, in 32-bit or 64-bit computer, it is 4 bytes multiplied by total number of elements. So, here the size of integer, if you take it, is 4 bytes multiplied by total number of elements is 10. So, it becomes 40 bytes. So, this is called the size of the array. Now, let us have a look at this array. So, this is an array of size 9. So, if you will declare integer a of 9, and this array contains 9 elements. So, array index, the array length is 9. Array index starts with 0. So, first index is 0 and the last index is 8 because array size minus 1. So, you can see that the indices starts from 0 to 8. These are the array indices. And it contains, because the array is of type integer, so it contains a number of integers. So, these are the integers 40, 55, 63. These are the integers stored in this array. Now, how to initialize an array? So, to initialize an array, we can directly write int a of 3, for example, is equal to 1, 2, 3. That means 3 elements you want to initialize. That means you need to understand the name of the array is A, containing 3 different slots which contains 3 integers 1 to 3, and their index numbers are A of 0, A of 1 and A of 2. Okay. Otherwise, if you will not specify the size, so here we normally write the size, array size. If you do not specify the size also, but you are allocating or you are initializing some values, then the size will be taken automatically. So, here the compiler automatically takes the size of the array is 3. So, both the ways you can initialize an array with some values by mentioning its size or without mentioning its size. Okay, so the compiler allocates memory for that array during compilation based on the array size. Now, if you will simply declare an array, this is called array declaration. So, this is called array declaration. Now, while declaring an array, if you do not mention the size, then the compile time error you will get as the size is not specified. But if you are initializing it with some values, then compiler will automatically compute its size by the number of values you are storing inside the array. So, this way, only for declaration, you cannot leave its size, you need to mention its size. Next, if you are writing integer a without mentioning the size, but you have given some values, then it is a valid declaration. Compiler automatically takes the size to be 4 because 4 values you are storing or initializing into the array. So, once the array is declared, the address of the array is fixed and it cannot be modified. Now, suppose in this example, you can see that val is an array, value array it is, and whenever this array is declared, suppose I am writing integer val of 7. So, in this array declaration, this is value of 0 in this is 1, 2 and up to value of 6. These are the indices. Next, whenever the array is declared, the memory is allocated for storing 7 integers. So, what is the size of this array? Size of this array is nothing but it is each element is an integer. So each element requires 4 bytes and the size of the array is 7. So 28 bytes is allocated for this array. So each integer requires 4 bytes. So these are the values that is stored inside this array. So these are the values. And these are the addresses, the memory address where this 28 bytes of space the array has got. So that will have a starting address. For example, it is 88820 up to 88844. So these are the addresses it has got. So first memory address, if it is 88820, then the second memory address will be 88820 plus 4. So it is like this. The starting address is 88820 plus size of each location is 4 bytes. So it is 88824. Next will be again 4 bytes you have to add. So 88828 and so on. So 4 bytes is nothing but the size of the integer which is added to every location to find the address of the next element. Okay. So here, suppose if you are writing value is nothing but the name of the array, is the array name, which also acts as a pointer to the array. That means it also contains the address of the first element. The address of the first element is stored into the array name. So array name by default acts as a pointer. So array name always contains the address of its first element, or you can mention like this. So what is the address that is contained by this array name is nothing but the address of the 0th element. Address of the 0th element. So the array by default acts as a pointer. Similarly, if you want to find out the address of the next element, suppose array plus 1. So which is nothing but the address of a of 1. If you want to find out, which is nothing but address of a of 0 plus 1. So which will give you the address of 1. So a of 1 will contain if you want to find out the address of this element, then the address of previous element plus the size of one cell or 1 byte or 4 bytes, which is nothing but the size of integer. If it is a character array, then the size of each character is 1 byte. So you have to find out like this. Suppose I want to find out address of a of 2, which is nothing but address of a of 1 plus 1 slot or 1 location you have to proceed. Now, once you declare an array, the compiler allocates memory and that memory is fixed. For example, you can see here, suppose there are two arrays, integer a of 10 and b of 10. As soon as these two arrays are declared, there will be some fixed address or starting address of this array. Okay, so array A will have an address and array B will have a different address. Okay, both are given the memory allocation has been done in two different areas of memory. Now, if you are trying to assign A is equal to B, that means you are trying to assign the address of B to the address. You are trying to store the address of B into the address of A, which is not possible. So you will get compile time error if you are trying to assign a new address to A. Because if you will try to understand that A is an array and B is another array. Suppose the index numbers are from 0 to 9 and here also the index numbers are 0 to 9. Now, A will have a different address. Suppose the address of A is suppose 2000, address of B is suppose 3000. Now, A and B are having two different addresses. Suppose A contains the starting address 2000, which is nothing but the address of this array A, that is the 0th element. Okay. Similarly, B is acting as a pointer which contains 3000, that means which is pointing to the array B. It is the 0th index, first index up to 9th index. So, these two addresses are different. So, if you are trying to do A is equal to B, that means you are trying to assign the address of B into address of A. That means once the array is declared, its address is fixed. You cannot modify it. That is the reason you will get compile time error. So, be careful that whenever you are dealing with the addresses, then you have to be careful. Addresses cannot be modified. Now, let us look at another small example. Integer a of 3, there is an integer array, and what you are trying to store, there is an array, integer array containing 3 locations, a of 0, a of 1 and a of 2. You are going to store one integer 1 and you are trying to store a character a, and you are trying to store one float value 3.8. Now, how it will store the character and a float value into an integer array? So, that time it will convert the character A into its equivalent ASCII value. So, 65 will be stored into this area. And whenever you are trying to store a float value here, then it cannot store a float value, but it will truncate its your fractional part and it will store only 3 into this area. Now, if you are trying to print the value of a of 0, a of 1 and a of 2, you will get the output as 1, then 65 and 3. You will get the output as 165 and 3 because it is an integer array. So, automatic type conversion will take place while storing the values and also while retrieving the values. Now, if you talk about the types of array, then the arrays can be single dimensional, 2-dimensional or multi-dimensional. So, when you increase the number of dimension, then how will you access the array elements? Now, first let us talk about the 2-dimensional array. Now, a 2-dimensional array is also a collection of data elements. So, each element of same type and same size. Now, in a 2-dimensional array, there are 2 types of your indices. One is called the row number and the column number. So, while declaring, you have to write down the data type followed by array name, and within bracket, you have to write down the row and column. So, this is the general declaration of a 2-dimensional array. So, if I am writing integer a of 2, 3, integer a of 2, 3 whenever you are writing, then you have to understand that it is nothing but a 2 by 3 matrix. 2 by 3 matrix with 0th row and first row and 0th column, first column and second column. And each value will have the index positions. So, what is the index position? The first value will be at 0th row, 0th column. Second value will be 0th row, first column, 0th row, second column. Similarly, this is first row, 0th column, first row, first column and first row, your second column. So, these are the indices or index positions using which you can store an element or you can retrieve an element. Okay. So, this is a 2 by 3 array. So, you can see here, this is at 0, 0, this is at 0, 1, this is at 0, 2 and this is 1, 0, this is 1, 1 and this is 1, 2. So, 0th row and first row, 0th column, first column and second column. Now, if somebody will ask you, what is the value that is stored at second row, third column? Second row, third column, then you have to understand that second row, because the index number starts with 0. So, this is the second row and the index number starts with 0. So, this is the second column. So, what is the value stored here? The value is nothing but 6. So, the second row, third column value is represented or accessed as A of 1, 2, first row and second column, which is nothing but the value 6. Okay. Now, like single dimensional array, while declaring the array or assigning some values, can you omit the number of rows or number of columns? Yes, it is possible. So, for example, here, int A of, I didn't mention the row size, but I have mentioned only the column size. But I have initialized the array with some values. 1, 2, 3, 4, 5, 6 and 7, 8, 9. So, how many data elements are there? 9 data elements are there and there are 3 groups are there. Each one is called a row. So, automatically compiler decides that it is a 3 by 3 matrix or 3 rows, 3 columns. So, if you do not mention, but if you have assigned the values or you have done initialization, then from the array initialization, automatically it will decide how many rows and how many columns are there. So, we can generalize now. If array name is just given then it is nothing but it stores the address of the array. Okay. Similarly, it is same as storing the address of 0th element. Okay. Or so ARR or ampersand ARR or ampersand ARR of 0 all means the same, which is nothing but the starting address of the array or the address of the 0th element, or it is the array acts as a pointer. The meaning of all these three are same. So all these addresses point to the first element in the array. So this is about two-dimensional array. Similarly, you can write a multi-dimensional array by increasing the rows, columns, or how many. If you want to represent a three-dimensional array is nothing but how many two-dimensional arrays are there. Okay. If you write down a four-dimensional array, it indicates how many three-dimensional arrays are there. So you can increase the dimensions in the array. Now, let us talk about how to pass an array to a function. So, if you want to pass an array to a function, then there are three ways are there. One is called a formal parameter as a pointer. You can pass an array, and you are passing an array means you are actually passing the address of the array. So, the address of the array can be received at the function side as a pointer. Similarly, you can pass the array as a formal parameter as a sized array. Suppose I am passing an array of size 10, then you have to receive it as the array of size 10 only. So here, without using the concept of pointer, you can receive the array as a sized array. Next, you can also receive as an unsized array. So let us discuss some programming related to how to pass an array to a function, followed by we will do a number of programs, we'll execute a number of programs related to array concepts. So let us switch over to the Dev C++ compiler and start executing our programs. Now, first let us understand how to pass an array as a formal parameter and receive it as a pointer. So, first program is related to a formal parameter as a pointer. Now, let us start with the header file #include stdio.h int main and return 0. Now, let me declare one array of size 5 and let us initialize with some values like 5, 4, 3, 2 and 1. So, an array with initialization. So, this is called array initialization. The size of the array is 5 elements, and let us call a function print and pass this array and its size. So, I am calling a print function over here and passing the array and its size. Now, the concept is here how to receive the array as a pointer. So, let us write down the print function. The print function returns nothing. So, void name of the function is print. It receives the array as a pointer because whenever you pass an array, you really pass the address of the array. So, write it down as this is an integer array. So, int star ptr, and you are receiving the size, which is nothing but a size, array size you are receiving. Now, let us display the content of the array. So, let me write down a loop. So, I is a looping variable. Write down a loop for I is equal to 0, I less than the array size followed by I plus plus. So, I am writing a loop to print the content of the array. Now, how to print the content of the array? So, using pointer, we will print the content of the array. So, each array contains integers. So, %d. So, size, that is the ampersand of the name of the array is ptr plus I. So, initially I is equal to 0. That means it is going to print the first value. Then I becomes 1 and it is going to print ptr plus 1 is nothing but the address of the first element. ptr plus 0 is nothing but the address of the 0th element. Star means the value stored at that. So which is nothing but here it will be like star PTR of 0. Then followed by the value which is there in the address PTR plus 1 and so on. So it is the address PTR plus 2 is the address and the value in that address. So like that this loop will run 5 times and the array contents will be printed. Now you can also print the same thing by writing like this: integer I is equal to 0. I less than the size of the array with I plus plus. So here we can also write like this: percentile D, comma, PTR within square bracket we can write I. So because PTR and PTR plus 0 both means the same. So here the meaning is PTR of 0 is nothing but the PTR of 0 is same as PTR plus 0. So here we have used the concept of pointer. Here in this case we are using the concept of we are using the array name itself as a pointer. So you can print in both ways. So let us save this program and run it to see the output of this code. Now you can see in this first example 5, 4, 3, 2, 1 and in the second for loop also it is printing the same 5, 4, 3, 2, 1. So let me remove this and put a /n here, printf /n to do the better formatting. You can see the output as for both the loops. These are only two different styles of receiving an array and using the concept of pointer to print the content of the array. This is called a formal parameter. The array is passed as a formal parameter and receives as a pointer. So hope it is understood. Now let us go for the second way. The second way is a formal parameter passed as a sized array. Now let us do one thing. So we'll copy paste this code and change it. Now here the concept is the array is passed as a sized array. So how to receive a sized array and do the operations? So we have taken in the main function, we have taken an array of size 5 and we have stored the values 5, 4, 3, 2, 1 and we are passing an array. So after this it is clear. Now let us receive the array as a sized array. So what is the size of the array? We will not write it as a pointer. We will write it as a of size 5. And the array size is same, the number of elements we are receiving. Now let us declare one looping variable I and print it. So we will write down for I is equal to 0 for I less than the size of the array and I plus plus. Now simply you can print the array elements by writing a of I. So here we are not using the pointer name, we are using the name of the array itself and we are receiving the array by its name as a sized array. So what is the size of the original array? That is a of 5. So we have received as the same sized array and we are using the same array name to print its content. That means here you have to understand the array name by default works as a pointer. The array name itself contains its address. So we can print the content of the array like this. Now let us save this. Save this program as a .c file and run it. So you can understand over here the output of this is 5, 4, 3, 2, 1. Same, the content of the array we have displayed. Now let us go for the third way, that is how to receive the array as an unsized array. So let us copy paste this program. So a formal parameter passed as an unsized array. So whenever you will pass it as an unsized array, then how will you? Then we will remove this size from here and let us try to print it. And let us see that what is the output over here. So this is the third concept. So only the difference is the previous code and this code is here we are receiving the array as an unsized array. So I have removed the array size. Okay. Now the remaining part is same. So we are writing a for loop to print the content of the array. Let us run it and check it. So you can see that if you will pass it as an unsized array also. So we have passed the array from using its address. So in that address, these values are there. So you have passed the address of the array. So you need to understand here. So automatically it will compute that how many values are there in that array. So you are getting the same output as 5, 4, 3, 2, 1. So these are the three different ways of passing an array to a function. Now, after this concept, let us understand a number of problems related to arrays. Now we'll go for find the output of the code. Let us declare hash include stdio.h header file and let us write down the structure of the main program. Now, suppose there is an array B of size 3, 2. That means 3 rows and 2 columns. So, total how many elements are there? 6 elements are there in this array. And let us initialize this array with some 6 elements. So, 6 elements we have initialized. Now, if you want to print the content of 0th row and first column, then what will be the value? Similarly, if you want to print the content of second row and first column, similarly, if you want to print the content of 0th row and second column, similarly, if you want to print the content of second row and fifth column, then what will be the output of this code? Now save this program. Right. Now this will give you row number 0 and column number 1 we are talking about. Okay. Here we are talking about row number 2 and column number 1. So here we are talking about row number 0 and column number 2. And here we are talking about second row, row number 2 and column number 5. Okay. Now from this you need to understand 3 by 2 matrix it is. So 3 rows are there, 0th row, first row and second row. And how many columns are there? Only 2 columns are there. That means here column number 5 is not there. So let us check whether the array boundary checking is going on in C language or not. We can understand through this code. So 0th row, first column. So it is a valid one. So let us check the output first. Now you can see the output. 0th row, first column. So the value is 20. Yes, it is correct. Then second row, first column. Second row, first column. It is 60. Yes, it is correct. Because it is the last value. Okay, second row, first column. Then 0th row, second column. 0th row, second column. So it is also correct. How it is taking? So you have to understand the the matrix format what you understood. So every element will have an address. So 0th row, second column is 30. And when you are going out of boundary, then in C language there is no out of boundary checking. So it will not throw any compile time, it will not throw any error, but it will simply say that it is having either garbage or 0, depends on the type of compiler. In Dev C++ compiler, you will get in that index you have 0 value. Okay. So in some compilers, you may get a garbage value also. So here this is because array boundary checking is not there in C. Array boundary checking is not done in C language. That is the reason you are getting the value as some unknown value you are getting. So it is compiler dependent. Either you may get 0 or you may get some garbage value. Okay. So this is the output. Now let us go for the next code. So find the output. Now let me go for a 3-dimensional array to find the output. So let us copy this code and change the program. Now in this case, let us take different types of arrays. Let me take one single dimensional array of size 3 and initialize with some values 5, 6 and 7. And a 2-dimensional array of size 3, 2 where let us store some values as 5, 6, 7, 1, 2, 3. So 6 elements we have stored, and let us take a 3-dimensional array, integer C of your 3, then 2, then 3. What is the meaning of this? The meaning is 2 by 3. How many 2 by 3 arrays are there? There are 3 2 by 3 arrays are there. So 3 by 2 array is 6 elements into 3, 6 into 3, your 18 elements are there. So let us start writing 18 elements. We'll 1, 2, go on writing 8 elements, 18 elements. Then 17 and 18. There are 18 elements in this array. If you want to group it, then you can group it. Otherwise, if you directly write all the 18 elements also, it will automatically take that first matrix, 2 by 3 matrix will contain the first 6 values, next 6 values in the second matrix, and the next 6 values in the third matrix, it will automatically take. Okay. Now, let us print some of the values. So here in the 3-dimensional array, I want to print the value of 0, 0 and 0. The value which is there at 0th row, 0th column of the 0th matrix. Okay. So it is 0th matrix in that row number 0 and it is column number 0. Now the second one is C of suppose 0, 1, 2. It is 0, 1 and 2. That means it is again 0th matrix in that row number 1 and column number 2. Now next one, C of 1, 1, 1. Suppose if we take C of 1, 1 and 1. And let us remove this. So it is nothing but the first matrix, first 2-dimensional matrix in that row number 1 and column number 1. Okay, this way you need to understand. So let us save it and store it as a C program. and let us run it. So what is the value that is there at 0th row, 0th column of 0th matrix, which is nothing but 1. Yes, the output is correct. It is 1. Next, what is the value that is there at 0th matrix, first row, second column? It is 6. Correct. And what is the value that is there in the first matrix, first row, first column? It is 11, which is also correct. So this way, you have to analyze and understand the output of different dimensional matrices. Now, after this, let us go for finding the output of the code segments. Now, let us go for another code, find the output. Hash include stdio.h, int main, and return 0. Now, suppose there is a matrix A of size 4, 5, 3-dimensional matrix. It is 6. So, how many values the matrix is going to store? It is a 4 5 by 6 matrices are there. 5 by 6, 30 into 4. That is 120 values it is going to store. Now, if you will try to give the values like this, will it accept? Okay. So, the numbers are from 1 to 120 and printf the value which is there at a particular index number. So, it is A of suppose 1, 1 and 1. Then, what will be the output? Now, if you will compile this, then what you are getting? Let us check it. Now, you can see that the ... what you have written for the remaining values from 5 to 119 is not allowed to write in this way. So, you need to understand this is not allowed. So, either you have to write down all the numbers, otherwise using a loop you have to read those values. So, this way it will throw you an error. So, you need to understand this. Now, let us go for another example. Now, let us understand another code. Now, how to compute the transpose of a matrix. Now, transpose of a matrix is nothing but inverting the rows into columns and columns into rows. That will give you the transpose of a matrix. So, let us start writing hash include stdio.h, int main and return 0. Now, let us use some preprocessor directive and define the number of rows and number of columns. Suppose, let us define row as 4 and as defined column as 4. So, 4 rows, 4 columns. I have defined the number of rows and columns using the macro names. Okay. Now, let us define a matrix integer m of row and column. So, here row and column will be replaced by the values 4 and 4 is equal to 4 rows 4 columns means 16 values you will have. So, let us write down the 16 values. So, we have written the 16 values in the matrix. So, this is global declaration of the matrix. So, any function can access this matrix. Now, let us take some variables I, j and one temporary variable t. And how to do this program. So, exchanging the number of rows and number of columns will take 2 loops. So, for I is equal to 0, I less than 4, I plus plus. And for j is equal to 0, j less than 4, J plus plus. Write down the printf statement. Let us interchange the row and column number here. Okay. Now first write down and display the matrix. Then we'll think of interchanging. Okay. So if you'll see over here, if you'll write m of ij. So I'm just simply displaying the content. So here one temporary variable is also not required. Let us save this program and run it first. So it is not looking like in a matrix format. So let us first format it. Okay. Write down. After each row, let us write down one new line character so that it will look like a matrix. First, display the matrix. So you can see here, the matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is a 4 by 4 matrix. Now, in this, let us copy paste this code and change this to J and this is to I. Okay. Now, write down a message. The transpose of the matrix is just a formal message. Then save and run the code. Now you can see clearly the rows are converted into columns and columns are converted into rows. This is called finding the transpose of a matrix. So it's a very simple code how to interchange the rows into columns. So while displaying the values, just interchange the rows into columns and columns into rows. Now, let us go for another program. Find the output of the code. Hash include stdio.h int main and return 0. So, after writing the structure, we will go for the actual code. This is the general way of writing the C program. Now, let us take one character array which is storing one string India 2021. Now, take one character pointer star p is equal to this. That means assign the address of the character array to the pointer. So, character array itself can act as a pointer. Otherwise, you have taken a pointer. Here the meaning is the pointer p contains the address of the array. Now, let us print the string at a particular location. Let us write p will contain the starting address of the array. Then p of 3 minus p of 1. Okay. Now, if you will write like this, then what is the string? What value of the string will be printed? P contains the starting address plus the address of the third location minus the address of the first location you have done. So, what is the value that will be printed? Let us check it. Save this program, compile and run. Now you can see that address at third. So, nothing is coming. So, let us increase. Okay. I have just increased the content of the character array and now let us run it. So, nothing is coming on the screen. Why? Okay. So, here the address of the third element 0, 1, 2, 3 which is nothing but your I. So, the address of the third element is I minus you have done the address of the first element. plus the address of the first element. So if you will write like this, then what is happening to what the compiler understands, you have to analyze it. Okay. Now, if you will analyze that, starting address is okay. Suppose the starting address is 1000. Okay, no problem. Then plus the address. So address to address modification you are doing. Okay. The address of these two addresses, it cannot be added like this. Okay. Minus this. If you cannot perform like this. So it is, so you won't get any output on the screen. Okay. Now after this, let us go for another problem. Find the output of the code. Hash include stdio.h int main and return 0. Now let us declare one character array, character AR of size 100. Okay. Now for this character array, let us write like this. Suppose %d, comma. Read the values into the character array by writing scanf %s, comma, ARR. Okay. I want to read a string into the character array and then print the return value using the printf statement. Okay. So here the scanf is inside a printf statement. So first scanf statement will read a string and it will store into the array, and the return value is printed by the printf statement. Okay. So the scanf always returns the length of the string it has read. So let us check it. What value you are going to get. Now save this as a .c file and let us run it. So when you are running, it is the control is waiting that some input I have to give. Suppose I am giving my input as IARE. Now you can see that the output is 1. Okay. IARE is nothing but the string that it has read and stored into the array, and the return value of scanf is nothing but how many strings it has read. So how many strings it has read? It has read only one string. So the return value is 1. So printf prints 1 here. Hope it is understood. So this is the output of the code. Suppose let us rerun the program with a different string. Suppose I am giving my input as hello world. It's a string. Now still it is showing as 1 because hello world is a single string it has read. So scanf returns 1 to the printf function. Printf prints it as 1. So this way you can understand the code. Now let us go for another program. Find the output of the code. Hash include stdio.h int main and return 0. Now let us take one function which takes a pointer, character pointer, and declare one character array of size 100. In that, at 0th position, A of 0 contains a character A, comma, A of 1 contains a character B, A of 2 contains a character C, and suppose A of 3 contains a character D. Okay, so we have stored 4 characters at A of 0, 1, 2 and 3. Now to the function fun, let us pass the address of this array. So let me write ampersand A of 0. That means I am passing the starting address of this array. I am passing the address of the first element into this. Now let us write down the what is the function definition. Now this function returns nothing. So void name of the function is function and it receives that address. as a character pointer. Okay. Now it received the address through the pointer A. Now let us increment the pointer and A++. That means now it is pointing to the earlier the address was the address of the first element it was containing. Now A++ when you do, now it is pointing to the second element. Now print the value or print the character which is there at that place. Now comma star A. So print the value at that address. Now again I want to increment the pointer by doing like this A++ and print the character at that address star A. Okay. Now this way what will be the output of the code? Now let us save it and run the code. Now you can see here that initially it was pointing to the character array, that is the starting address we have passed. So at 0th index it was containing the character A, but inside the function you have done A++. That means now it is pointing to the character B, and whenever you are printing that character you are getting as B. Again you have incremented the pointer, so now it is pointing to the third character, so which is nothing but C, and you have printed it, so we are getting B and C are the two characters at that location. That means here you need to understand that how array is, how you have passed the array and it is working as a pointer. So the formal parameter here as a pointer you have received. Now let us go for the next program. Find the output. Hash include stdio.h int main and return 0. Now let us declare one array of size 1 which contains a single element 10. So this is called array initialization process, and after that let me print the content of the array by writing 0 of ARR. Okay. Now will it work or not? You need to understand over here ARR of 0 is same as 0 of ARR. It is allowed in C language. Okay. So whether you write down the index inside the square bracket or you write down the index outside and the array name inside, both are same. So if you will print like this, you should get 10 as the output. Okay. Now let us go for save this program and run it. Now the output is 10. So here you need to understand like this. So let me write down different ways. So first way is writing ARR of 0. Which is same as 0 of ARR. Or if you are using the concept of pointer, then you can also write ARR of plus 0. You can also write, if you are using a pointer concept, then you can write ARR of plus 0 is nothing but the address, and if you will put a star, the value in that address you will understand. So if you will save it and run it, then square bracket is missing. Let us put the square bracket and run the code again. So you can see here the value 10 and 10 are printed. Both means the same. Similarly, let us modify this code and check the output of some other code. So integer ARR of, suppose there is an array which contains number of elements let us store some elements into the array as 2, 3, 4, 1, 6. Okay. Now, let us print percentile u. U is unsigned. You can write percentile u, percentile u, percentile u. Normally for addresses we write percentile u as unsigned because the addresses are never negative. Okay, but you can also use it for integers. So you can write ampersand ARR of 0, the address of 0, and you can also write ampersand of ARR. Now here you are trying to print the address of this array. So all the three are same, ARR of 0 or ampersand ARR of 0. So ARR of 0 contains a value. So let us check it. Ampersand ARR of 0 and ampersand ARR will give you the same thing. Now you can see here, ARR of 0 will give you the value. So at 0th index, the value is 2. At 0th index, the value is 2. But ampersand ARR of 0 is nothing but the starting address of the array. So it is some 6487552 is the starting address of the array. You can write like this, or you can write ampersand ARR. That is the address of the array. Both are same. So you need to understand the difference between the value and the address. How to print the value and the address over here. Now let us move on to the next example. Find the output. Hash include stdio.h int main and return 0. Now let us define an integer variable int I and one character array, so which initially contains a null character. Okay. Now if printf percentile s comma a, okay, if you want to print the content, let us write down a message printf the string is empty. The string is empty because it contains a null string. Else write down printf the string is not empty. The string is not empty. That's all. So what will be the output of this code? So here we have declared, so here the integer variable is also not required. We have declared one character array and stored a null string, and we are printing that. So what will be the output? You can see here the string is not empty. Okay, because printf, what it will return? Printf percentile s, the content of the array you are printing. So it contains a null string. So it returns 0. So if condition is false, that's why you are getting the output as the string is not empty. Okay. So this way you need to understand the code. Now let us move on to the next code. Find the output. Hash include stdio.h int main and return 0. Now let us declare one character p and one character array, character buffer. The name of the array is buffer of size 10, which contains some numbers. Okay. So 1, 2, 3, 4, 5, 6, 9, 8. Some numbers it contains. Okay, it's a character array. Now, let us do P is equal to buffer plus 1 of 5. Okay, now if you write like this, then what will be the output? Buffer contains always the starting address. Buffer plus 1 of index 5. So, it's very interesting. So, if you will print that value, then what will be the output? So, store it as. So, save the program and compile the code. Now, you can see here the value is 9. Okay. So, you have to analyze how you got. So, this character array contains some integers, but we are displaying what values? We are displaying only the integer values that it stores. So, how it stores internally? It stores through its ASCII value. And we are displaying the value. So, here buffer plus 1. Buffer plus 1 is nothing but the address of the first element. So, from there, fifth index. Okay. So, from there, fifth index is nothing but 1, 2, 3, 4 and 5. Okay. So, now it is the starting address is now at the address of the second value, that is 2. So, from there, fifth index. So, this is 0th index is at 2, then 1, 2, 3, 4 and 5. At the fifth index, we have the value 9. Okay. This way also, you can write down the code. In this video, we understood the concept of arrays, single dimensional and multi-dimensional array, followed by we have executed a number of programs using array concepts in C language. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.